Hello, everyone, and we are live. Let me know where you're chatting from here in the chat on the right or at the bottom. I'm always so confused with this YouTube live, YouTube comments. So, whatever you can, whenever you see, just write it in the comment for us. I'm going to invite our speaker now, and he's going to introduce himself, talk about his talk. We were just chatting before here. He's based in Israel, and we just really are curious to know everything Kubernetes he has to share. So I'm going to invite him now. Hello and welcome.
Hi everyone, my name is Shimon Tolts, and yes, I'm live from Israel.
Yay, what time is it there?
So it is 8 p.m.
Very good. Here in the UK, it's 6. So I'll leave the stage to you. We're very excited to hear about you and your talk. So the stage is yours.
Thank you very much, Amanda, and it's an honor to be here. Um, so I'm really, really happy for you to have me here. And what I'm going to talk about is a topic that is very dear to my heart. It's regarding Kubernetes and how to manage it with the different policies. And I'm going to show you, it's a hands-on technical talk, and I'm going to show you how you can do it with the Conftest and GateKeeper and Open Policy Agent. Don't worry if you don't know what those things are, but I'm going to tell you more about it. So feel free to engage with me using the chat. Hi Raja, hi Iheb, hi everyone. Feel free to ask any questions that you might have. So a little bit about myself. So as I said, my name is Shimon. I'm 32 years old, and I'm a co-founder of a startup in the DevOps world. And surprisingly enough, we are in the area of preventing misconfigurations from ever reaching production. And in this talk, I will show you how you can actually build your own policy enforcement solution, and I'll go deeper into it in my talk. A little bit background about myself. I have more than 10 years experience in R&D management and tech. I'm also very avid in the community. I'm an AWS Community Hero, which is similar to Google Developer Expert, only the Amazon version. And I'm also very active. I'm the co-organizer of the Cloud Native Foundation Group in Tel Aviv, CNCF, and also run a CTO club. And I'm going to tell you my story and why it prompted me to actually go and start a startup. And I'll tell you more about it and how we got there. So um, moving on, today we're going to talk about OPA. And what is OPA? It is an open policy agent, and it is part of the CNCF, the Cloud Native Foundation. So everything here is open source, and it is um, supported by the community and by the sponsors of the CNCF. Now, Open Policy Agent used to be an incubating project, but actually it recently graduated, and now it is a graduated project, much like the Kubernetes project. So it's a great honor, and it's really, really amazing, and it's like a first-class citizen, and it is widely used. And today I'm going to show you how you can write policies and use it. So in today's talk, we're going to talk about what is OPA, what is Conftest, what is Gatekeeper, and what are the use cases for it, and also some real world examples. So I'm going to show you some code, not too much, don't worry about it, just enough to get you interested and for you to be able to try it by yourself. So a little bit about Datree. So as I said, we are a 3 years old company. We're well established, well funded, and we help prevent Kubernetes misconfigurations from ever reaching production. So it's a CLI that you can install, and it has a lot of the rules that I will show you pre-built. And so you don't need to code the policies yourself. You can use a centralized policy management solution like ours, and it integrates together with all of the ecosystem. But if you want to know how you can build something like that by yourself, this is the topic of today, and I will show you how it is going to be done. So, little bit of a story time regarding how we got here. So, you know, you have a company, you start developing, you move to Kubernetes, you have developers, you run into production, everything's amazing, you love it. Kubernetes runs your company and it's amazing, everything is codified, you have YAML files for your configuration, maybe Helm files, Helm charts in order to manage it. And then one day you notice that you had a production outage and there was a problem because a node ran out of memory. So you go and look at what happened and you find out that actually someone forgot to put in a memory limit in the manifest file, and then the Kubernetes orchestrator killed it, or the node ran out of memory. So you see this and you say, okay, let's make sure that everyone works this way. And this is a true story. In my previous job, I was an engineering manager of the infrastructure division for 400 engineers. And we had a problem. And some developer made a mistake, and it's okay, everyone makes a mistake. But then you ask yourself the question, how am I supposed to propagate this development standard to everyone and actually make sure that they don't make the same mistake again? So you send an email, you think that you're going to live happily ever after. 2 weeks after, you have another production outage. And we all know how this goes and what can you do? And what happened is that the developer, this is a picture of one of our developers, her name is Noah, just as an example, she forgot to put in a memory limit in her manifest. So then you ask yourself, so what can you do? What can you actually do in order to do this? So you say, okay, so now DevOps is going to review all of the Kubernetes changes that happen in my organization. But that's an anti-pattern. Like, you don't want everything that a developer makes to have to go through a approval process of the DevOps. You want to delegate infrastructure as code responsibilities. You want to give them the freedom. You want them to have the ownership, and you want them to wake up at 5 in the morning if they have a problem, and not the DevOps or operations or SRE team, because you want the developers to have the ownership. So it's really not feasible to say DevOps will just review everything and babysit the developers if they make mistakes. So we thought about it and we said there must be another way. And there is another way. And if we look at the DevOps side and the developer side, and by the way, some people call it DevOps, some people call it infrastructure, some call it SRE, some, there are many different ways to call it. And the best place that you can do is where everyone meets. And everyone meets actually in the CI/CD pipeline. Eventually, at the end of the day, you have the developers on one side writing code, coding features, and then on the other side, you have your automated processes, CI, CD, and then at the end of the day, something has to kubectl it into your cluster and to run it. So what if we had policies that will automatically act as a guardrail and actually check that the changes that the developers are making are according to our development standards that we want in the company? And guess what? You can actually do it. And you can do it with Open Policy Agent. And this is the open source project that we talked about. And you can ask yourself, so what actually is Open Policy Agent? So let's dive deeper into understanding what is Open Policy Agent. So it's a general purpose policy engine. So you can do different things with it, not only check for misconfigurations in Kubernetes files. You could also do things like, and many companies do, run authorization policies. So let's say someone connects to your microservice and you want to know if they're authorized. So you check if the policy that the user applies to can actually go and make the decision. And the idea is to decouple the policy engine side and the decision making from the business logic itself. So you might have a server that, I don't know, serves images, and then it can ask the policy agent, can this user receive this image. And the same thing, what we're going to do today, you can go and scan a manifest file and say, there is no memory limit. There should be a memory limit. Or there is a memory limit of 80 gigabytes and they're only allowed to use 4 gigabytes. So this is the logic of the policy enforcement. And the idea is that you can couple it with your microservices and they will query your OPA layer, and the OPA layer will act as a layer of logic around the policies. And this way you don't have to codify it into your microservices. Now, OPA has the ability to work in two different ways. But the main thing is that I think that the main benefit is that it decouples the decision making of the logic of the policies from actually the services themselves. So the way it works is you can either import it as a library, or you can have it as a centralized service, and you can run HTTP requests to it and ask it if the policy, if something meets the policy or not. In today's talk, we will mainly look at examples where OPA runs as a library. So for example, Conftest runs on top of OPA and OPA comes as a library. In Open Policy Agent, the way you work with it is you write policies. And the policies are written in a language, and the language is called Rego. You might have not heard of it, but it's a very, very simple declarative language. It was inspired by Datalog. Sounds like Datadog, but it's Datalog. And it's really easy to read. And like the example here, you can see package main and then deny and message. If it denies, it will send this message. Kind of looks a bit like Go, if people know Golang here. And you say, let's scan the file and for input kite deployment. And if we do not have the attribute input spec selector match labels app, then it will fail and it will send the message, containers must provide app label for pod selectors. And we will go deeper into the different examples in a minute, but I just wanted you to get an understanding of OPA and policy agent. So here's an example of running OPA as a service. So you download OPA, it's very simple, it runs on any platform you want, and you run it as a server. And you give it a Rego file to run policies with. And then you, in this example, you curl it. And as you curl it, you will, hold on, I want to move something. Let me try to do this. Yeah, great. Yeah, nice. Okay, so as you curl it, you will input a JSON file in this example, and then it will take the input JSON, run it against this Rego policy, and output the result for us if it passes or not. So you can do the same thing by importing the library and running it. Or you can actually have a server that will listen to it and will allow or deny different policies. So now that you get the understanding of what is an open policy agent in general, I'd like to dive deeper into what is Conftest. So, OPA is very generic. So Conftest was written, and it is also it is under the Open Policy Agent project in GitHub, and it enables you to test policies, and it's specifically designed to be used in CI or in local testing. And it's built on top of OPA, so the policies are written in Rego, and it enables an easy way for you to write tests on structured files. So today, the main examples and the talk is around Kubernetes, and Kubernetes uses YAML files. But you can actually use Conftest to test Terraform or any other structured files and run sort of like unit tests for configuration with Conftest. So Conftest is really easy. An interesting part is that, I don't know if you know, but the Docker registry today does not only hold containers, so it also holds Rego files and OPA policies. And because this is part of the OCI standard, and the OCI standard has incorporated the ability to use policies inside of it. So you can actually do conftest pull and pull a set of policies from a registry, and you can push policies into a registry. And the way it works and the way you perform tests is you just do conftest test, and then you say the file that you want to test. And let's look at the example. So you download conftest and you execute a test. Here is an example. So we want to make sure that we have a label called app. And if we do not have that, we will error and say that containers might provide an app level for pod selectors. And you will notice now that the output looks a bit like, like unit tests in Node.js or Java or whatever, Python or whatever language you prefer writing code in. So it already feels more like inside the development flow, and it is more friendly to developers. So if something fails, they can see, oh, amount of tests, amount of failures, and understand what fails. So let's look at where it fits inside our pipeline. So we get a feature, we code it, we submit it into Git, we open up a pull request, and then the CI pipeline kicks in. It builds our project, it runs unit tests, it runs integration tests, maybe with other microservices. And then at this point, you can run infrastructure tests with Conftest. And then if the tests here are failing, then at this point, the developer can see that there's a problem and fix it right away. So let me know if you have any questions so far. And let me show you a real life example of how Conftest looks like. So here, this is a Conftest test file, package main. Where you can assign variables, name equals, and then input is like what you give it. So let's say our Kubernetes file, and then metadata name. So in this case, what we're doing is we're checking that our manifest file for Kubernetes has all the recommended labels. So those are recommended labels by the Kubernetes project. This is what they actually recommend you use. So to have name, instance, version, component, part of, and so on. So this test will go and check if you do not have the required deployment labels. It will error and say must include Kubernetes recommended labels. And it's very simple. You just state the type of the policy that you like, the location that you want. And in this case, it's really easy. Obviously, there are deeper examples where you can go and check if something exists, or greater than, or less than. Um, um, you like whatever you can imagine you can do. And here is an example of how I can actually take this test. So we have the test to check if we have labels, and then we want to incorporate it into our CI/CD. So in this case, I'm showing the example of GitHub Actions. Very popular. A lot of people use it. It's just integrated within GitHub. So you can pull the Conftest container, and as you can see, it sits under the Open Policy Agent namespace. And you can pull the container and pull the policy and actually run conftest test and test all of your Kubernetes YAML files. So in this case, I pulled the conftest container, I pulled my policy from my internal OCI registry so I can have my policies, and then I apply it on my folder, on everything that exists under the kube folder. And this is how you can incorporate Conftest inside of your CI. But what if you have criminals? What if you have people who try to push in stuff into Kubernetes without actually going through the CI/CD? Maybe they just kubectl something directly into your cluster. This is highly unrecommended, but if you want to have an even stronger layer of enforcement, you can choose to use the project Gatekeeper. And what is Gatekeeper? Gatekeeper is actually a policy enforcement solution for Kubernetes that runs on the cluster itself. So the way it works, it listens as an admission webhook to the admission controller, and then every time there is a command submitted to Kubernetes, this hook is invoked and it calls Gatekeeper to check whether the things that are submitted are good and that they are valid to go into our cluster. So let's see how we can use it directly within our setup. So how does Gatekeeper work? So let me explain a little bit more about admission controllers. So if people are familiar with operating system programming, it's like handles or hooks in operating systems, where every time that someone wants to apply something on our cluster, the admission controller says, oh, hold on. Let me look and see whether you can actually perform that. And then it goes and talks to Gatekeeper, and Gatekeeper runs a set of tests. Now, the way it integrates within Kubernetes is admission webhooks. And for those who aren't familiar, there are two types of admission webhooks in Kubernetes. The first one is called a mutating webhook. And a mutating webhook is it runs and it runs first and it can modify objects. So you can actually make a webhook and say, every time I'm spinning up a resource, add a mutating webhook that will perform a mutation on the command and add Shimon to the name of the webhook. So that's an example. And this is a mutating webhook. A validating webhook happens after a mutating webhook, and it is invoked at the end after all objects are modified, and then it only checks whether the status is okay or not. So as you can imagine, a Gatekeeper runs as a validating webhook at the end, because first you have the mutating webhooks and then it goes into validating webhooks. So I have a question from Raja. How do I get a sample JSON of my intended deployment to write tests against kubectl dry run? I see. So actually you need to get the files and run it on Conftest. If I get your question right, if I understand your question. Maybe you can clarify a little bit more if it's around Gatekeeper or Conftest. So let's go deeper. So how does a Gatekeeper work? So you can define a constraint template, and it works with Rego. So the nice thing actually is that they both use Rego. And the way it works is that you can basically send the same. Hi Amanda, we have two Amandas. Interesting. So you can actually run the same policies in Conftest and GateKeeper, which is really nice because you can leverage the same policy and check it in different locations. So first you define a constraint template, and it describes both the Rego files and the schema of it. And then you run GateKeeper, and it runs inside Kubernetes with a validating admission hook, and it can block changes. So let's look at how it looks like. So this is a constraint template, and a constraint template, so you can see it's just a Kubernetes file. So API version, templates, gatekeeper, kind constraint template really looks like, very familiar, right? Looks like a kind deployment. Metadata, Kubernetes required labels, and then spec CRD, and then you give it a CRD, and you say it's Kubernetes required labels. And then it goes and says, look, you actually have to have a property label of type array and items in the types of string. And this is how you give it the schema of what it should actually look for. So we can see that we need labels, that it will be an array, and it will be an array of strings inside of it. And then you say, what are the targets? So where should I apply those rules? So again, it starts like in Conftest violation, because like it's a violation if it's not true. And message, and it tells you you will have missing labels. And then it actually checks if you have a metadata labels label. And then it checks if it's an object because it's required. And then it's actually looking for if you have something missing between the provided and the required. And then if the count, and if the count is 0, it says, okay, if the count is like more than 0, then it says you have a problem, you have missing labels, but otherwise it's okay, and it lets it be. So I don't want to go too deep into the code. I hope it makes sense. You define your policy schema, then you perform the test itself by saying, like in tests, what is the actual, what is the expected. You check whether the actual and the expected are the same and matching. And then this is how the test runs. And then, as you can see, you can use Kubernetes required labels as a constraint template to make sure that the label is defined. In this case, so labels. In this case, it's to look at namespace and labels gatekeeper. And together with that, you can configure your gatekeeper to be integrated within the development workflow. So let's recap. And we're coming to the end of our session. But we have some more time for questions if you want. So by doing this, what we want to do is we want to actually make sure that we codify our development standards and policies in order to make sure that people are programming and defining Kubernetes resources under the guidelines that we want. Make sure that they have a liveness probe and readiness probe and memory limit and CPU limit and so on. And the way that we want to do it is using Open Policy Agent, Conftest, and GateKeeper. And the way we will do it is we will write Rego files and configuration, Rego policies. And on the one hand, it will run on Conftest. And Conftest in the CI pipeline will check whether it's working or not. And it will notify the developer right away and fail the build if there is an issue. And then you can also do it in the continuous deployment in the CD pipeline. So once you review, stage it, you build a container, you have an API, you ship the container, and then you want to submit an API call into Kubernetes. Gatekeeper will intercept it and will run the tests on the actual live production environment or staging, whatever your cluster is, and it will check that it is according to your policy. And this way you can build an end-to-end policy enforcement solution from CI into CD. Now, as I said, if you want, we at Datree, we have a built-in solution that does everything for you and you don't need to codify it. It's just Datree.io. But I'm happy to answer any questions that you might have. And to recap the topics that we had, anyone that wants to contact me, feel free. Those are my details. I'd love to answer any questions you might have, or feel free to reach out on Twitter, LinkedIn, and so on. And thank you very much for attending my talk. It was a real pleasure to be hosted virtually at London.
If you have any questions, please write it in the chat.
And if for any reason we didn't have time to take your question, you can always reach the speaker with the contact that they left here.
Or you can just type it on our Slack channel. We monitor it every day and you can get engaged with our community.
We look forward to hearing from you.
Thank you very much. Thank you for having me, Amanda.
Thank you for coming here. We love your energy, how much you know about the topic, and being here, doing this for free for the community, for all of us. Thank you so much. So everyone, final moment, final minute. If you have any questions, drop it in the chat. Otherwise, as we said, you can reach out to him. He's just left his email here in the chat. Let's give someone, maybe they're finishing to type something. Otherwise, we're going to finish.
Yeah, I'm just going to send also the project's GitHubs.
Great.
And it's also good if people don't have much questions. They're still engaged, but they understand, so it's cool.
That
so
is
I'm going
true.
to
People were engaged all the way.
Yeah, so I'm sending the both projects, GitHub projects in the chat, so you have that, Conftest and GateKeeper. They're both in Go, and you can submit pull requests if you want. Thank you very much. Thank you for having me.
Thank you. Have a good evening. Night
You too.
now.
Thank you. Bye-bye.